So chlorine atoms in nature exist as isotope 35, 37 with abundance of 3:1. It is natural abundance. Human beings do not participate or not responsible for such a type of abundance of elements. And for your information, all the elements of the periodic table have isotopes. That means such abundance exists for all. This data of abundance can be expressed in ratio. If you express as a ratio, it is 3:1. You can call one ratio part as M, other as N. You can have fractional abundance. If you have fractional abundance, then 3 part out of total 4 parts. So 3/4. 1 part out of 4 parts. 1/4. So fractional abundance is F1, other one is F2. And if you can note, addition of F1 and F2 is 1. Fractional abundance, right, all added together is 1. Percentage abundance. You know, 3/4 is what? 75%. Yes. And 1/4 is what? 25%. So if you want to write down the same data, you can write down 75% is to 25%. One is P1, other is P2. Where P1 and P2, if you add together, is 100. Imagine 3 isotopes would have been present. Then F1 plus F2 plus F3 would have been 1. Similarly, P1 plus P2 plus P3 would have been 100 if 3 isotopes would have been present. Imagine if 4 are present, F1 plus F2 plus F3 plus F4 would have been 1. Similarly, P1, P2, P3, P4 would have been 100. But now we are dealing with only 2 isotopes. So we have only 2 factors. For all chemical calculations, what would have been correct to take atomic mass of chlorine? Should I take 35 or should I take 37? Science says it is not scientifically correct to either take 35 or you should take 37. On the other hand, science says you take a proper average of the 2 isotopes taking into account their abundance. Based on these factors and argument, average atomic term was introduced in the science. Question is, when is this term average atomic mass introduced? Average atomic mass term is introduced whenever you have isotopes. The question is, which elements of the periodic table have isotopes? Answer is all elements. That means in short, all elements, you should use the word average atomic mass. Average atomic mass, therefore, is given by this formula if M and N are the ratio and A1 and A2 are their atomic masses. A1, A2 are atomic masses. F1, F2 are fractional abundance. A1, A2 are atomic masses. P1, P2 are percentage abundance. Correct. These are the 3 formula. Which formula should I use depends how the data is given, or we conveniently write down that data. For chlorine, right, if you ask me technically, this formula will be far better. Oh, there was an error. It should be divided by 100. It should be divided by 1 because F1 plus F2 is 1. But 1 you don't consider. So for chlorine, average atomic mass will be F1, A1 plus F2, A2. So 3/4 is abundance of 35. 1/4 is abundance of 37. If you solve 142 divided by 4, 35.5. And if you remember, in mole concept and stoichiometry, we took average atomic mass of 35.5 for calculation purpose. This is one type of a numerical. Another type of a numerical is they give you all the data, but now they ask you to calculate percentage abundance. If such type of a question comes up, then right, to do second type of a numerical, remember, take one fractional abundance as x. Yes, we are aware they ask you percentage. Still, we take fraction because it is convenient. Let one fraction be x. Other fraction will be 1 minus x, because you know sum of the fractional abundance is 1. This method is convenient when two isotopes are involved. Then use this formula, substitute the data, calculate the value of x, which will be decimal number or a fraction. Multiply that fraction by 100, you will get percentage. Example, find percentage abundance of lighter atom of neon 20 and neon 22. If average atomic mass is 20.4, right, you remember the trick, right? They are asking for lighter atom. Lighter is neon 20. Let that lighter atom be x. Then what will be the fractional abundance for other isotope? Correct, 1 minus x, because fractional abundance together is 1. Average atomic mass is given by the formula F1 A1 plus F2 A2. First fraction is x, other fraction is 1 minus x. You open up this bracket and solve that unknown. That unknown value will be 0.8. Oh, convert this into percentage. That is 80 percentage. So percentage abundance of lighter isotope is 80. If somebody asks you for heavier isotope, it will be how much? Answer is remaining percentage